Okay, welcome to this lesson. We are going to look at what is the mid-segment theorem. All right, so I'm going to summarize this very quick. It says that a mid-segment of a triangle is a segment that connects the midpoint, right, of the two sides of a triangle. So this is the midpoint. Now, what's so peculiar about this? Well, look at this. If it does connect, okay, then it says that the segment is half as long as the opposite side, the parallel side, okay? So if this is 5, this is 10. Why? Because this is half as long as this one. Now, let's look at this in action. All right. So it says, given DE, DF, and FE, okay, these are the lengths of the mid-segments of a triangle. It says, find the perimeter of triangle A, B, and C. Okay, so what do I know? This segment is a mid-segment. It connects the midpoints. So if this is 8, then this AB must be 16. Okay? And it says it right here. 8 is half of 16, so AB is 16. Then 7. Now we have to look at parallel, okay, sides, parallel segments, okay? This does not belong to this one, and this one doesn't belong to CB, okay? We're talking about parallel. This is parallel to this one. So this is 7, this is 14, so 14, okay? And now this is parallel to AC, so therefore, if this is 6, this whole thing is 12. Not only that, that also, if this is the midpoint, then this is 6, and this is also 6. You see that? All right then. So now the perimeter of ABC will be 12 plus 16 plus 14, which is 42. See, this lesson is very easy. Just remember, mid-segment. Okay, let's do our next problem. Let's see. We're gonna need a ruler here. So let's look at the problem. The problem says, and they are giving us the coordinates of each of the segments, right? And they want me to show that DE is parallel, this is the symbol for parallel, to BC. Okay, let's see what's up. Oh, and also show that DE is half of BC. All right, so we're gonna start plotting our points. Not a problem. The first point that I'm gonna plot is A, which is -2, -4. -2, -4. 1, 2, 3, 4. It's right here. See it? Okay then. So I'm gonna call this point A. Okay. Now the next point I'm gonna plot is B, 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And this is gonna be point B. Next point is C, so 6, -2. 6, okay, 1, 2, 3, 4, 5, 6, and then -2, 1, 2, and it's right here. The next point, oh gosh, let me see, that is C. Next point is D, 1, 2. 1, 2, right here. And that is D. Last but not least, point E, 2, -3. 2, -3. 1, 2, 3. Okay. 2, -3, and that's going to be point E. So what am I supposed to do now? I have no idea. I'm going to, let me see. A, B, C, D, E. Okay, 1, 2, 3, 4, 5 sides. All right. So show that DE is parallel to BC. DE. Where is DE? DE is right here. Okay. Is parallel to BC. All right. BC right here. Oh, look at this. Now I know. Okay. You see, you gotta make sense of the problem. Now I understand. Okay, what are we looking at right now? Mid-segments of a triangle. So I'm gonna do triangle ABC. It doesn't say anything about ABC, but I'm gonna connect A like this. See that? Now I hope you're doing it as well. All right then. So how am I gonna prove that this DE is parallel to BC? Well, hello. Remember, parallel lines have something in common. So what am I gonna do? I'm gonna write it right here. Okay, parallel lines have the same slope. So let's calculate the slope of DE. The slope of DE can be calculated either going from this point, from E to D, or from D to E. It doesn't matter. I'm going to go from D to E. So I'm going to go 1, 2, 3, 4, 5, and 1 over. Now, because I went down, okay, the slope of this line is negative. So I'm going to say that the slope of DE equals negative 5 over 1. Now let us calculate the slope of BC. So I'm going to write already the slope of BC, okay, equals, and now we are going to calculate the slope of BC. So let's see how many down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down, and 1, 2 over to the right. So it's 10, okay, negative 10 over 2, which if we simplify it translates to negative 5 over 1. See that? Okay then. So guess what? They have the same slope. So parallel lines have the same slope. The slope of DE is, and I'm going to actually label it as a segment, okay? The slope of DE is negative 5 over 1. The slope of BC is negative 5 over 1. Therefore, and you have to write this down, therefore, DE is parallel to BC. Okay then. What else it's included in this problem? Well, it says show that DE is half of BC. Show that this DE is half the length of this. So I can tell you right now that it is because of what the mid-segment theorem, but it's not that easy. Okay, first I am going to actually figure out the lengths. How? By looking at the coordinates. So let us actually go over here. Okay, so what are the coordinates of D? The coordinates of D are 1, 2. What are the coordinates of E? The coordinates of E are 2, negative 3. Now, question. I'll give you 1 point if you answer this question. How can I find the length of DE? Okay, so I'm going to use the distance formula. All right, so I'm going to use the distance formula. Now, for those of you who don't remember what the distance formula, in my classroom, you can look in the back and you'll see. Now, the distance formula says that you have to have the difference of the two x's. So I'm going to call this x1 minus x2, and then you got to square it, plus the difference of the y. So y1 minus y2 subscript, okay? y2 square. All right, so now let us plug in. All right, so I'm going to have these the ones and these the twos. Perfect? Okay, so that's exactly what I'm going to do. So let's see. x1, so 1 minus x2. Well, this is the x coordinate, so, and then square it. Plus the difference between the y's. So I got the 2 over here, because, you know, if you go from left to right, you got to keep it consistent. 2 minus, and then the other one is negative 3. So 2 minus negative 3, and I'm going to square that. Okay. So 1 minus 2 is negative 1. Square is 1. Plus 2 minus negative 3, that's 5. Square is 25. Okay. Now the distance here is radical 26. Okay, so that is the distance. And just to be sure of that, let us actually calculate what the square root of 26 is on the calculator. Okay, so the square root of 26 is 5.099. Okay, so this is approximately, okay, 5.09901. Cool. Now let me find out what the distance of BC is. So wait, I'm not gonna take this away. I'm just gonna go here. All right. Let you copy. And now I'm going to find out the distance of BC. So what are the coordinates of B and what are the coordinates of C? So the coordinates of B are 4, 8. The coordinates of C are somebody tell me, 6, negative 2. All right, so now we know how to find the length. I'm going to use the distance formula. I'm not going to write it down because you already have it in your paper. I'm just going to help you solve the problem. So let's see now. I'm going to call these the 1s and these the 2s, okay? Is that fine? Is that fine? Yes, okay. So x1 minus x2 square plus, oh gosh, let's see. No, it's fine. Okay, 4 minus 6 plus, and then a y1 minus y2, which is negative 2, okay? And now, let me show you how to put this on the, square. Let me show you how to put this on the calculator. The way I put it on the calculator. So, you take the square root, okay? You open parentheses, so that tells the calculator not to close the radical sign. And we're going to write the following. So, 4 minus 6 square, all right? Close the parenthesis, we already closed it, plus, open the parentheses again, and we'll do 8 minus, and this time I am going to actually show you something. Minus, the minus is right here, minus. But the calculator has a distinction between the minus and the negative. So minus, negative, okay? So now we're back to normal. Minus, negative 2. Close parentheses and square. Okay? Now, what you get is 10.1980 and blah, blah, blah. So how am I, now let's go back here. How am I going to determine if this is actually half of this? And you know what? Just for the sake of doing it, I'm going to show you. 4 minus 6 is negative 2. Square is 4. So I'm just going to write it over here, the radical representation. Okay, so 2 square is 4. Plus 8 minus negative 2 is 10. 10 square is 100. So this is nothing more than radical 104. Okay? Now the funny thing is that, of course, radical 26 is not half of radical 104, but that's not the point. Okay? Because we're not calculating radicals, we're calculating distance. Okay? Yes, this is the radical representation, but this is the decimal representation. So what we're going to do is we are going to take that number that we had right here, okay, this one, and we're just going to divide it by 2. Okay, I mean, that's what my common sense tells me. I don't know about you. Oh, look at that, beautiful. Oh my God. So, I just proved that segment DE is half of BC. Okay? So, we can write, segment DE has a length of 5 blah, 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 and segment BC has a length of 10 point blah, blah, blah. Therefore, DE is 1/2 of BC. You like that, right? All right, let's move on because we took too long on this problem. All right. So, here you go. This is basically, oh my God, we just did everything for nothing? No, not really. We actually solved the problem. And now, as a gift from me to you, this is basically the diagram right here. Okay? You have everything explained in a much neater way. Maybe not more clear, but much neater. So you see? Okay. And then we have this one right here. All right, that's on your next page. So I'm just showing it to you. Wow. And remember something, I didn't even look at this page. I'm nice. So you see 104. All right. And then, oh wow, look, when you simplify radical 104, you go to B and H. No. You end up with 2 radical 26. Okay, now this you could say that is twice as much as radical 26, which was the length of DE. All right. All right. So let's move on. All right. Let's go on to the easy questions now. All right. Stop saying all right. Just do it. How much money? How much money? Okay. In the diagram below, okay, you need to read the problem. Once you read the problem, then this gives you the measure. So we put the measures. Right. AC is 10. So AC is 10. So this one right here is 10. So the whole thing is 10. Okay. Then AT is 18. AT is 18. Cool. CT is 22. CT is 22. This whole thing is 22. Okay. No problem. So what am I to do? Well, it says, okay, it says, what is the perimeter of the parallelogram CDOG? Ha ha ha, be careful with the questioning. Be careful with the questioning. You see, you thought that by looking at the diagram, they were going to ask you for the length or the perimeter of this triangle here. No, they're asking you for the perimeter of the parallelogram. And you know what? Let me see if I have a color pencil so I could actually do it for you. So this right here, okay, the CDOG, CDOG. This is what they want. Okay, so let's do this. Okay, this segment is parallel to this segment, and we're talking about a triangle. And okay, at the beginning of the problem it says midpoint. Therefore, we're talking about mid-segment. So this is parallel to this one. Therefore, this is 5. Makes sense? Good. Then, if this is 5, this is also 5. All right. Now, the distance from here to here is 11. How the hell do I know? I mean, it's not like it says it. Wait. It doesn't say it, but it's implied. It's telling you that from here to here is 22. And we're talking about midpoint. So therefore, from here to here is 11. Make sense now? And this is also 11. That's it. So now let's find the perimeter. Perimeter, distance around. So 11 plus 11 is 22. 5 plus 5 is 10. So 22 plus 10 is 32. Bada bing, bada boom. We have found our answer. Okay? Cool. Let's move on to our next problem. All right. So what am I supposed to do here? I have no idea. It says in the diagram below of triangle ABC, okay, D is a midpoint of AB. So D is a midpoint and E is also a midpoint. Therefore, we're talking about a mid-segment, and this is half the distance of this. So this is 2x plus 5. And you know what? Why am I going up ahead if I don't even know what I'm gonna be asked? Okay, no problem. If AC is 4x plus 10, which is here, which expression represents DE? Oh, DE? Beker, you OD man, be still nice. Okay, so that's what we get. Now, let us move on to our next problem. Okay. It says, in the diagram below of triangle ABC, DE is a midsegment. Boom, midsegment. Okay. So DE is 7. So DE is 7. AB is 10. Okay, this is 10 right here. No problem. And BC is 13. BC is 13. Okay, so you see how I draw the whole arc all the way to the other endpoint? And I don't stop here? Okay then, find the perimeter of triangle ABC. I need the perimeter of triangle ABC. My God, this is like 4th grade math. We know that this is half of this, so this is what? Nice. So let's find the perimeter. 30 seconds. Do it. Okay, so the perimeter is 37. That's it. Obvious. So guess what? On the regions, don't just write 37, okay? I am just writing 37 because I know what it is. But on the regions, you must write the following. The perimeter, okay, of, and then a triangle ABC. Please do it once, see it forever, is 37. And remember something. If they tell you that it measures 7 inches, 10 inches, and so on and so forth, then you say that the perimeter is 37 inches. If they don't say anything, just put 37 units. All right. Okay, let's move on. All right. So once again, we more or less know what we're dealing with because this is the midsegment. Now, do me a favor. You should, okay, if you're watching this video, you should try to pause the video, look at the problem, try to do it yourself, and in pencil, of course, and then check with me, okay, check the answers with me. Okay, let's see now. What is the length in centimeters of EF? They want EF. Information. Oh, wait! Key piece of information. It says that in the diagram below, the verse of DEF, okay, are midpoints of the sides of an equilateral triangle ABC. So ABC is equilateral, therefore this little triangle is also equilateral. And now it says that the perimeter of the whole thing is 36. So I know that the perimeter in an equilateral triangle, since all sides are equal, the perimeter is 3 times each side. In other words, 3 times each side means side plus side plus side, right? So, and the perimeter is 36. So, we just solve the equation for S. How do I solve for S? Easy, divide by 3. So, each side of ABC is 12 what? 12 centimeters, because they gave us the measures, the units. So this is 12, this is 12, and this is 12. Therefore, this is 6, 6, 6. Makes sense? So now, what is the length in centimeters of EF? 6. There you go. Okay, let's move on to our next problem. And you see how I'm showing work? I expect you to show work as well. Unless you're not my student. Even if you're my student, it's nice to show work. All right. So again, another problem. I know, practice makes perfect. All right. So in the diagram below ABC, below AB is 10, BC is 14. Okay. So look, they give us the labels. Okay. Find the perimeter of the triangle formed by connecting the midpoints of the sides of ABC. Okay. So let's find the midpoints. Now, do I really need to use the compass and go like, okay, the midpoint is found when I do the perpendicular bisector of each side, and I go like this, and then I do that thingy that we do with the perpendicular bisector. No, it's just an estimate. Okay, so let's just estimate. Okay, midpoint here, midpoint here, midpoint here. Okay, it's not like they're asking you to to construct. If they ask you to construct, you construct. If they don't ask you to construct, you don't construct. Okay. Now in life, we're not like this. In life, if we have to help somebody, we help that person. Okay. All right. So this is 14. What is the measure of this side right here? 7, right? What is the measure of this side here? 8. Okay. It's okay to call out. Okay. If you know the answer, just raise your hand and boom, boom, boom. That's it. All right, and the measure of this side is 5. All right, so what do I want? Perimeter of this little triangle? Sure. I'm going to do 8 plus 5 plus 7. 8 plus 5 is 13. 13 plus 7 is 20. So you don't just leave it like that. You're right. The perimeter of, okay, the triangle formed by connecting the midpoint of, just rephrase this, okay, and then you put is 20. Cool. All right, let us do some more over here. All right, so on the set of axes below, graph and label D. Oh gosh, okay, triangle DEF with verses this and that. Okay, so that is the first thing I'm going to do. Why? Because it's telling me to to graph those the points. So let me do it. Boom, 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 boom. Yo, Bex, I just realized something. You're not using music. Yeah, because every time I do it, like something pops on YouTube and says, Anyway, guys, I'm waiting for you to plot the points. Oh, I'm drinking some cool water. Yes, it is water. All right, so I'm gonna keep silence while I plot the points. D. It says connect them, right? Then just wait for me, do it. At this point, I shouldn't be teaching you anything. You should already know this, and you should build upon that to create your own conclusions or conjectures. All right, so I did, right? Now, and why do I label it on the graph? So I know which point corresponds to what. All right, so what else does it say? If G is the midpoint of EF, okay, G is the midpoint of EF. How do I find midpoint? Well, you know what? Let's do this full throttle. Let us actually do the whole thing. So G is the midpoint of EF and H is the midpoint of DF. So let's find G first. So this is EF. Okay, now I'm going to find the midpoint. Now I'm going to show you that I can already see where the midpoint is. The midpoint is right here. Okay, by deduction. I can conclude that. All right then. Now, H is the midpoint of DF. DF. So I'm going to find the midpoint of that, which is H. So let me see now. I think this is the midpoint right here. It has to be. All right. Now, just in case, I'm going to show you what I showed you in previous lessons. If you already have a segment and you want to find a midpoint, just find a slope. So look at this. 1, 2, 3, 4. Okay. 4 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I have again 1, 2, 3, 4. So the slope here is 4 over 10. 4 over 10. Guess what? It's negative. Yeah, fine. I don't care about that. I'm gonna show you how to find a midpoint from that length. So this is the slope. So just chop the slope in half. It becomes 2 over 5. So let's see if it's true. 1, 2. 1, 2, 3, 4. Beker, you said G. Okay. And what are the coordinates of this point? 3, 0. Okay. And the same process goes over here. So look, the slope from here to here is what? Well, let's see. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 2 over 12. So 2 over 12, okay? So chop that in half and you get 1 over 6. So let's see, 1, and then 1, 2, 3, 4, 5, 6. Here's a G, Beker. Okay, by the way, this is G. This is point G, and this is point H. All right, so point H. The coordinates are 2, negative 3. 1, 2, 3. Yes. So it's 2, negative 3. All right. Woo. Now, what is the proper way, I guess, to find the midpoint? Then that will be using the midpoint formula. So fine, I'm gonna use the midpoint formula. Okay. So how do I do that? Easy. So I'm gonna find a midpoint from E to F. So I need the coordinates of E and I need the coordinates of F. So the coordinates of E are negative 2, 2. And the coordinates of F are 8, negative 2. Okay? So the midpoint formula says, find the average of the x's and then find the average of the y's. Okay, so let's find the average of the x. How do you find average? You add and divide by the amount of numbers. So you have negative 2 plus 8. Negative 2 plus 8. Okay? And then divided by 2. Okay. So what is that? Negative 2 plus 8 is 6. 6 divided by 2 is 3. See that? And now I'm going to find the average of the y's. So I'm just going to do it without doing too much calculation. So 2 plus negative 2 is 0. Divided by 2, 0. Make sense? And if you're in doubt of the midpoint formula, well, for my students, just look in the back of the classroom. There's a big sign that is telling you what the midpoint formula is. So it works. Now, this is basically, I think, I'm not sure, okay? But I think this is what the people in the regions want. Like, they want you to use the midpoint formula, so you use it. So you found EF, and then you have to find the, okay, so that's 3, 0 right here. And then you find the midpoint of DF, which that would be H, of course. And then the coordinates, okay, using the same procedure. Okay, then. Back to the problem. So, what else does it say? State the coordinates of G and H. Oh, we did that. What else? And label each point on your graph. Explain why GH is parallel to DE. Alright, guys? This is the moment you've been waiting for. Explain why GH, that means this point right here, this segment. Now we have to connect it because they say it's a segment. So I did connect it. Okay? And why is this parallel to DE? Okay. 2 ways. Okay, you could say because they have the same slope. For example, and you know what? I have space on the side, so I'm going to find the slope of GH. The slope of GH equals, and you notice that it's going up like this. Okay, I'm going to go from H to G. So I'm going to go 1, 2, 3, and then 1 over. So the slope is positive 3 over 1, or just 3. What if I had gone from this point to this one? It doesn't matter. 1, 2, 3 down, that means negative. And then 1 to the left, which means negative. Therefore, negative over negative will still give you positive. All right, now let's find the slope of DE. Okay, what is the slope of DE? Easy. I think it's going to be 6 over 2 because this is half of this. So anyway, so let's see now. 1, 2, 3, 4, 5, 6. 1, 2. Boom. I knew it. 6 over 2, which is the same thing as 3 over 1. So now you can say in writing, of course, that GH is parallel to DE because they have the same, what? They have the same slope. Not only that, I could just say the following, okay, assuming that, okay, they assume that you already know the theorems. Okay, so look at what I'm going to write. Actually, I can just write it here. Oh my God, where am I going to write it? Oh, I know. Let's just go here. Okay, so I'm going to say the following, okay? This is what I'm going to say. GH is parallel to DE because of the mid-segment theorem. Okay? Now, the thing is that you could say this one, but I think proving that they are parallel, it's a much better idea. I don't know, you could use both. Because remember what the mid-segment theorem says, right? Look, the mid-segment right here. Where is it? Right here. It says that a mid-segment connecting two sides of a triangle is parallel to the third side. So, look at this. You already had midpoint here. So this is a mid-segment. Get it? Because it connects the midpoints. So because it connects the midpoints, you could just give this explanation. Because of the mid-segment theorem. Because you have already proven it. Anyway, let's continue to the next problem. Okay, we're almost done with this lesson. Hope. Okay. So, let us go here. It says, in triangle ABC, point, oh gosh, don't tell me I'm going to have to do a visual. All right, point D is on AB and point E is on BC. Okay, so how do I do this? I'm going to use the ruler. I mean, if you want to use the ruler, fine. I really don't care. I just need a triangle. Okay, this is missing because I'm far away from where I'm writing because I gotta be looking at the camera. Anyway, so that is my triangle ABC. So I'm gonna call this A, B, C. I really don't care how I label it. It says point D is on AB. So point D is right here. Now look at where I'm putting plotting the point, because this is what we're looking at. Okay, this is all about mid segments. If this was a problem on the regions, you gotta make sure that you read the full problem. But since this is a lesson and we're already talking about mid segments, it's okay to put it right here. And point E is on BC. Okay. Such that DE, okay, DE, that means that when I connect it, okay, such that DE is parallel to AC. You see, this piece of information tells you that you are going to put this point like around the middle, okay? Because it's parallel. And remember, if it touches, then you know what's up. All right, so if DB is 2, DB is 2, DA is 7, DA is 7, and DE is 3. Wait. Oh, DE is 3. All right. What is the length of AC? Wait, hold on a second. They playing with us. Watch this. We're looking at midpoints, but this guy just says that DE is parallel to AC. This is not the mid-segment theorem. And how do I know this? Because I've seen this before. This is the SST, side splitter theorem. And how do I know that? Well, because they make no mention of something being a mid-segment or something being half as long, or they're not asking me for the perimeter or the area. They're asking me for the length of AC. So that means that all I have to do is separate these two triangles. Remember how to do that? Well, let's do it together. So the little triangle is right here. And this is going to be the big triangle. Okay. The little triangle label will be D, B, and E. The big triangle is going to be A, B, C. Wow, this is great, and hopefully you guys notice as well, because they would have given me a full length over here. Watch this. How did I know that this was not the mid-segment theorem? Because the measure here is 7 and the measure here is 2. If it was, guess what? This would also be 7. So it's tricky. And not only that, this is 3. If it had been the mid-segment, this would be 6. But there is no choice here that says 6. So you understand how, you see where I'm coming from, my man? All right. So let us do this. So this is 2. This is 3. Okay. AB is 9. Okay. AB is 9. 7 plus 2. All right. And BC, I have no idea, but they're not asking me for that. They're asking me for the length of AC. So AC, I'm going to call it X. All right. So now all we have to do is compare sides with sides. Okay. So let's see. 2 goes to 9. So 2 is to 9 as 3 is to X. All right. So now I cross multiply. So I get 2X equaling 27. I divide by 2 and I get 13.5. Nah, nice. All right, so you know what? I'm not gonna assume anymore because these guys are tricky. Okay. In the diagram below of triangle ADE, okay, ADE. See, now I'm being more careful. C is a point on AD, okay, such that BC is parallel to ED. Okay, they are parallel. So AC is X minus 3. AC is X minus 3. AD, the whole thing here, is 2X plus 2. Okay. BE is 20. AB is 16. Okay. So, what else? No, that's it. Okay, they want me to find the length of AC. They want me to find this length right here. All right, not a problem. So this is, again, this is not a mid-segment problem because look at the lengths right here. Okay, so I'm Gucci. What I'm going to do is I'm going to compare the small triangle to the big triangle, and this time I expect you to understand how to compare them. So the small triangle is this one, and the big triangle is this one. Okay, so 16 from the small triangle is going to be compared to what on the large triangle? You tell me, I'll give you 1 point. Okay, so yes, it's going to be compared to 36, which is the length of the full AE. All right, so 36. Okay, cool. Now, 16 is to 36 as X minus 3, which is the length of the small thingy, is to the length of the full thingy, X plus 2. Alrighty. Now we're going to cross multiply. So when I use the distributive property, 16 times 2x is 32x. 16 times 2 is 32. And that now is, I go here, and 36 times x is 36x. 36 times negative 3 is, I have no idea, so you tell me. Okay, is, ouch, I hit the camera. 108. Okay. And now I solve the equation. So I have variables on both sides. So I'm going to subtract 32x from both sides. So this becomes 4x. And I'm going to add 108 to both sides. Okay. So that becomes 140. Now, guess what I'm going to do? Right. I'm going to divide. So x becomes 35. And you know my usual question. So this is the answer. I always ask if this is the answer because it usually is not. Remember what they asked you for. They asked you for the length of AC. They asked you for this length right here. So if x is 35, then 35 minus 3 is 32. So you're right. Okay? Length of AC equals 32. That's how you do it. All right, cool then. So let's get on to the last problem of this lesson. Let's see now. Okay, here we go. So in the diagram below, triangle ABC, D is a point of CE is 25, so CE is 25 inches. So we're talking about inches now. Pause. AD is 18. Okay, 18. AD is 18. Okay. DB is 12. DB is 12. Okay. What else do I know? Find to the nearest tenth of an inch the length of EB. They want me to find EB. So I'm going to put an X here because I have no idea what it is. All right, then. So let us just compare. So watch this. The lengths are on the outside of the triangle. Okay. Sometimes, actually no. Most of the time when the length is in the inside, I compare the two triangles, the small one to the big one. But when the lengths are outside and you have almost everything, it is okay to just compare each segment. In other words, this is what I'm going to do. I'm going to do it both ways. So the first thing I'm going to do is I'm going to do it the old-fashioned way, which is comparing the two triangles. All right, so X from the small triangle, okay, corresponds to the length of the large triangle. So what is the length of CB? The length of CB is not 25x, just in case you're saying. It's 25 plus x. Because if this was a 2, the length would not be 50 in terms of like 25 times 2. Okay? Because that's what you would be saying. You would be saying if you're saying 25x. No, it's 25 plus x. Because if this was 2, 25 plus 2 is 27. So anyway, so 25x, and that compares to, and now I'm going to go to 12. I started comparing the small triangle to the large one. So this is the small triangle, 12. And that goes to what? Well, 18 plus 12 is 20, 30, right? Okay. And now, when I cross multiply, I end up with, okay, so let us do some math right here. 12 times x is 12x, right? And 12 times 25 is 300. Okay, and now I did this cross multiplication. Now I'm gonna do this one. 30 times x is 30x. Okay. Now the next time when you cross multiply, this should be over here and this should go over here. It doesn't matter. Okay, so now I am going to subtract 12x from the whole thing. So what is 30 minus 12? 18. So this becomes, so 300 equals to 18x. Okay. Wait, I have space. Oh, I have blank space over here. I can continue then. Okay. Now I'm going to divide by 18. You know that, right? So that is 16.6666666666666667. Okay. Okay, so that was one way of doing it. That's the old-fashioned way. Now let us do it the the shortcut way. But of course, remember, only when the lengths are given on the outside. If one of the lengths is given right here on the inside, forget it. You have to compare one triangle to the other. All right, here, since the lengths are given on the outside, all you have to do is compare segments of the same side. So I'm going to say x is to 25 as 12, because I started with the small one, okay, as 12 is to 18. Okay? So now when you cross multiply, you get 18x equaling 300. And then when you divide by 18, well, you already have it right here. When you divide by 18, you get 16.66666667. Now, watch carefully. The problem says to the nearest tenth of an inch. So, okay, so that's why to the nearest tenth of an inch. This is to the nearest 100. This is to the nearest 100. So to the nearest tenth, sure. 16.7. See that? 16.7. As simple as that, okay? No sweat. All right, guys. So this was a lesson on mid-segment. And not only that, we encounter a couple of problems that did not have to do with the mid-segment. They had to do with the side splitter theorem. But I hope you, if we already learned this, I hope that it was helpful. All right, guys. I'll see you on the next lesson.